Earth's invisible shield is not equally strong everywhere. From space, our planet appears wrapped in a single magnetic field that quietly deflects dangerous charged particles. It is often imagined as a complete protective shell surrounding the world, yet every modern map of that field contains the same unsettling feature. Over the South Atlantic Ocean and eastern South America, the shield bends inward. Measurements reveal a broad region where its strength drops far below what satellites encounter almost anywhere else around Earth. At first, that sounds like a scientific curiosity. A slightly weaker magnetic field should not matter very much. After all, nothing looks different from the ground. The sky remains the same. Compasses still point north. There are no visible warnings that anything unusual exists above this stretch of ocean. Then the measurements refuse to fit that assumption. Magnetic surveys from orbit repeatedly identify the same basin of weakened field strength. At its center, the field falls below about 22,000 nanoteslas, dramatically lower than much of the rest of the planet. Scientists gave this region a name, the South Atlantic Anomaly. The discovery changes one belief immediately. Earth is not surrounded by a perfectly uniform invisible shield. That raises a more important question. If one part of the shield is weaker, does anything actually happen? The first answer did not come from people. It came from machines. As spacecraft crossed this invisible region, radiation detectors suddenly climbed. Electronic systems that behaved normally elsewhere began recording unexpected errors inside the same geographical boundaries again and again. The pattern was so consistent that engineers stopped treating the events as isolated failures. They were entering a place that demanded different rules. One of the clearest examples circles Earth every day. The Hubble Space Telescope spends much of its life observing distant galaxies, exploding stars, and the oldest light in the universe. But several times during its orbit, the telescope approaches the South Atlantic Anomaly. Before it enters, automated commands begin shutting down sensitive scientific instruments. High-voltage systems are switched off. Observations stop. Only after leaving the region do normal operations resume. Nothing crashes. Nothing explodes. The telescope simply refuses to work there. That routine interruption appears again and again throughout its operating schedule, creating repeated gaps in scientific observations that line up almost perfectly with the same section of Earth's magnetic map. The invisible dent has become a real operational boundary. Other spacecraft tell similar stories. Satellites designed to measure Earth's oceans and atmosphere have recorded bursts of electronic memory errors while passing through the anomaly. Tiny changes occur inside computer memory. A stored 0 becomes a 1. A 1 becomes a 0. Engineers call these single event upsets. The name sounds harmless. The consequences are not. One flipped bit can corrupt scientific measurements, interrupt onboard software, or trigger automatic recovery systems. Most spacecraft survive because they are built to expect these events. Error correction, protective shielding, and carefully planned operating procedures reduce the risk. Technology has adapted. But adaptation is not the same as eliminating the problem. That creates another shift in understanding. The weakness inside Earth's magnetic shield is not simply measurable. It changes how humanity operates in orbit. For years, it would have been tempting to imagine the anomaly as a permanent feature, an inconvenient patch of space that engineers had already learned to avoid. The newest measurements challenge that idea as well. Modern magnetic surveys conducted by dedicated mapping satellites reveal that the anomaly is changing. The weak region is drifting westward over time. Its overall shape is evolving. Even more surprising, what once appeared to be a single basin is developing a second minimum closer to the southwest coast of Africa. The dent in the shield is no longer behaving like a fixed scar. It is becoming more complicated. The discovery forces another replacement of the viewer's mental model. The magnetic shield is not standing still. It is moving. that naturally leads deeper. If the shield itself keeps changing, where does the change begin? The answer lies far below the continents and oceans. Thousands of kilometers beneath our feet, Earth's liquid outer core slowly circulates. Vast movements of molten iron generate the magnetic field surrounding the planet. But that engine is not perfectly centered or perfectly symmetrical. The magnetic system it creates is offset from Earth's geographic center. That asymmetry matters. Above the South Atlantic, part of the inner Van Allen radiation belt descends much closer to Earth than it does elsewhere. Instead of remaining safely higher in space, energetic trapped particles dip toward the altitudes traveled by many satellites. The shield has not torn open. Space has not punched through the atmosphere. Instead, the geometry of Earth's magnetic protection quietly changes where dangerous radiation can reach. The consequences appear hundreds of kilometers above the surface, while life below continues, almost completely unaware. Even this explanation has limits. Researchers can map the anomaly with remarkable precision. They know where it is. They know how it changes. They know how spacecraft respond when crossing it. What they cannot directly observe is every turbulent movement inside the liquid outer core that produces these evolving magnetic patterns. The deep engine remains hidden. Its behavior is reconstructed from measurements taken at the surface and from orbit, not from direct observation. That uncertainty does not weaken the discovery. It defines it. Earth's magnetic field is one of the best measured planetary systems we possess. At the same time, its deepest driving processes remain an active investigation. The South Atlantic Anomaly is the visible fingerprint of that hidden engine. Seen from a distance, Earth still appears wrapped inside a graceful, invisible shield. Now the image carries a different meaning. That shield is not a flawless shell surrounding the planet equally in every direction. It is a living planetary system whose strength changes across space and through time. One region quietly bends inward. Satellites prepare for it before they arrive. Instruments fall silent while they pass. New maps continue to reveal that the weak spot itself is still evolving. Nothing about Earth's appearance has changed. Only our understanding of the protection surrounding it has.